Hello, everybody. It's great to be participating in the Python Web Conference here, and I hope this is an exciting and somewhat fresh topic for this event. I am the director and founder of an open source product and I guess a family of products and a community called the Open Concept Lab. Look forward to talking more about that during this conversation. I'm also a senior consultant with the Regenstrief Institute, which is a health informatics nonprofit research institute in Indianapolis that's affiliated with the university there, and also an adjunct at the Boston University School of Public Health, where I teach on topics related to digital health solutions, in particular in low and middle income countries. And so today, what I'll be talking with you about is the specific product, the Open Concept Lab, and how organizations and countries that are working in low and middle income countries and trying to tackle some of the world's biggest health challenges are using this type of tool and related tools. And so to start, really is why is this interesting? Why is this important? Why does software like this exist? So within global health, if you're not familiar with this, there are lots of global health challenges throughout the world. We could look at it from basically any facet, from child mortality, where there are, excuse me, 6 million children excuse me, under the age of 5 that die each year. Maternal mortality during childbirth is an enormous problem. We have HIV/AIDS is a significant challenge, especially in Africa, but in all parts of the world. Mental health is now becoming recognized as a leading cause of disability and morbidity worldwide. And of course, now we're seeing even pandemics beyond what we've seen in the past, like the flu, but also things like COVID that are impacting all of us and even impacting this conference. So digital health has an enormous role to play in this. Digital tools are what are allowing these virtual conferences to take place, but are also being used everywhere throughout the world to strengthen health systems and to address some of these big challenges. One of the big reasons this happened is something that everyone here is going to be familiar with, which is mobile health, or mobile technology is now pervasive throughout the world. That over the last 20 years, we've seen the majority of the world's population now have access to a phone. About half the world's population uses a smartphone, and majority of the connections that people have are 3G or higher. Even in low-income countries in urban areas, you're seeing LTE being rolled out now if it hasn't already been. So that creates enormous opportunity to leverage existing devices that people already have familiarity with to access health information and to improve health services. So what's the goal from the perspective of data use? So we think about this in two big ways. This isn't unique to health, but I've provided some specific health examples. There's first this primary data use, which is you're using data collected by a health worker for the specific service that they're providing. So a doctor or nurse enters your room and is providing care. They're going to capture data. They're going to review existing data in your health record. And they're going to use that at the point of service to provide better care. So that's primary data use. Secondary data use is all of the other things that you can do with it once you have it that you couldn't easily do if you collected that information on paper. So while this may seem like old news in a high-income setting, or if you're based in the US like I am, in low-income settings, this is still quite uncommon to be using electronic medical records and then being able to have all the derivative uses of data, such as for public health, for administering your health system, for doing broad surveillance about your population, for tackling some of the bigger issues that health systems have to deal with, like how do we effectively allocate a limited set of resources so that we can maximize the health of our population. So our goal is to collect data once and use it many times. So how do we do that? Well, within health system, you need to know a handful of things. It's the who, what, where, when, why of health data. So the who is you got to know the provider, you got to know the patient. The what is what are they doing? What's the provider doing? What are your symptoms, the diagnoses, procedures, the drugs that are administered? The where is your health facility and your location. The when is typically captured in that patient encounter that's captured in the electronic medical record. And the why is then getting inferences from all of this content and all of this data. So this is reporting information in aggregate fashion, so you can look across your population and performing business intelligence on that. And so there are existing systems that we use to manage all of this information to make better use of it. So we have client registries and provider registries, a terminology services, which is what I'm going to talk about, a facility registry, a shared health record, and health management information systems. So what does that actually look like? So on the left here is a kind of a schematic or an architecture that is actually incredibly common throughout the world. We see this in national health, digital health strategies that are being published, not just in places like the US or Canada or Western Europe, but in just about every low and middle income country in the world. Their governments have legislated architectures like this, digital health architectures that are saying, how do we capture the who, what, where, when, why of health data and make use of it throughout our health system. But it turns out that a lot of the systems that are already being used in the world are primarily, and not surprisingly, targeting commercial entities. And so their business models, while appropriate in a well-resourced health system, don't work as well in health systems that are primarily publicly driven and that use a lot of donor funding. So we need different types of tools. So the Open Health Information Exchange community, OpenHIE, is a community of practice that has participants and members from all over the world that are helping to define these core architectural components that governments are using to help with primary and secondary data use and to help facilitate data exchange within health systems throughout the world. And they do this through defining standards, through defining the reference or requirements for the software, and then actually supporting the development of reference software applications for these architectural components. And so it's like I said, an open community practice that you could join if of interest. So just as an example to show that this is in fact something that is common throughout the world, in Ethiopia, and a project that I supported the development of their national e-health strategy. And this policy set was aligned to Ethiopia's health system goals and their financing strategy for how could we better make use of health data in our health system that we're collecting from our patients and our clients. And that has a few things. One is, how do you better digitize it? And then second, once you've digitized that data, how do you better use it? How do you do all those secondary uses of data? I don't want to jump into any of this in detail. This would take much longer than this session, but you will see a lot of the same systems all of the same systems that were in that OpenHIE architecture right here that we talked about for the who, what, where, when, and why. Are part of this architecture, and they show this master facility registry, a health data dictionary, and other systems with an interoperability service to help make that data be able to be exchanged and more readily. So like I mentioned, though, there are not a lot of systems that are compatible with the types of markets that exist in low-income settings. So a lot of what I'm going to talk about now is from a pretty new movement around digital global goods, which basically says what we talked about, that there is a gap in products that are available that are open source, that are interoperable, that are scalable, and that are applicable in low-income country and middle-income country contexts. And so if you're interested in this topic, take a look at the Global Goods Guidebook. I provided a link here. This is produced by Digital Square, along with lots of partners that you may be familiar with, like the World Health Organization, that documents standards for digital global goods, and includes a lot of different software systems that governments are already using or are investing in to be used in these contexts. So what is the Open Concept Lab? That was all the context for why is this session of interest. So the Open Concept Lab is addressing one of those architectural components. It is addressing the terminology service piece of it. A terminology service is a cloud-based system that helps governments to manage their data dictionaries or their standardized terminology, to publish it massively within their health system, to create massive availability of standardized terminology within their health system, and then to help their stakeholders use it. So this is, in summary, to collaboratively manage, publish, and use your metadata. Terminology services already exist within the for-profit space. This is one of the only open source, cloud-based, and community-driven products of this type. And it's being used in a number of environments, including Ethiopia, and by PEPFAR for management of terminology related to HIV/AIDS treatment and service delivery throughout the world. So I want to dive in quickly to show you some examples, because I think for a lot of things that are technical, that are in the weeds, that it's easier to just take a look at specific examples, and then I'll continue with the slides. So OCL you can find it at openconceptlab.org. It's centrally hosted, which is important because health systems typically have had to implement their own terminology services, but that could be a significant undertaking in some of these environments. So so you could take a look here at openconceptlab.org if you'd like to follow along. It's a free service for some level of functionality, and so we have a number of organizations that have already published what we would call their national or their health data dictionaries. So what does that mean? So let's say you are a clinician and you are interested in, or you have a patient that has entered your clinic that you diagnosed with malaria, and you're trying to capture or document their diagnosis of malaria in your patient health record and make sure that it's reported in a way that is consistent with the rest of your countries, how everyone else in the country is reporting this information. So you may come to a tool like this and search for malaria, and here you'll find a malarial fever diagnosis, and you'll see that this has a preferred name, malarial fever. It's a diagnosis. There's no data type for this. There are a number of different synonyms, each in different locales. So we have English, French, Spanish, and others. Each synonym or each locale could actually have many different synonyms, because for a more complex diagnosis, you often have a clinical term, and then you might have terms that are used more when you're interacting with the client. And you want to allow people to be able to search for a term based on all of the different ways people refer to that. Each of these has its own identifier, so that if you were creating a clinical form, you may need to be able to link to a specific name here. The same method applies to descriptions, where you could have any number of types of descriptions, any number of locales, and those could all be captured here as well. You could have any number of custom attributes that are associated with each concept or term that you've defined in your dictionary. There are none for this, but if you imagine that instead you had one that was blood pressure, we can look that up in a moment. You'll see that there are custom attributes that are used to define its permitted ranges and support with the interpretation of that data. Finally, something that's really critical in the standards world is mapping. So it's not enough to just say this is malaria fever often, because usually you need to be able to report data outside of just the organization or the country in which you are capturing that data. Meaning it needs to be something that's understood at a global level. So you would map then to some of the global standards, such as the WHO, the World Health Organization's ICD-10 classification. This is the International Classification of Diseases. So you could take a look there and see the WHO's code for malarial fever as well. And then this has same as maps to a number of other terminology dictionaries that are used throughout the world. So that's kind of the basic idea of a single definition. So if you imagine that Ethiopia has gone through this process and they've said, they've defined their own national classification of diseases here. And so we could take a look. Here's a source of the repository, if you want to use that. You'll see a lot of this is modeled after the GitHub kind of structure. So that their national classification of diseases it has about 2,000 terms or concepts, we call it. So concept is the most abstracted idea of a clinical concept. So 2,000 diagnoses, and we could say if we were a clinician in Ethiopia, we might say, look up malaria and find term number 196. This would be the code that is entered on a form. Everyone else in the country at a public clinic would be using this. And like we saw before, this is the same as mapping to the WHO's term B50.9, which is and here's the fully specified name for that, and in the clinical terminology world, which is this Plasmodium falciparum malaria, unspecified. And that means that it doesn't matter if you're in Ethiopia or if you're in Canada or if you're in Nigeria, that all of those countries are mapping as well to WHO's International Classification of Diseases. And now we could start to use this to measure the global burden of disease throughout the world. So that's the quick example of what types of content exist in OCL. So there are a number of tools that we have developed or that are under development that are part of this kind of toolkit. And so the first, what we were looking at, is the OCL authoring interface. This is a place you would go to if you are an administrator or, say, a health terminologist or an informaticist. It's a type of tool where you could actually manage, curate, make some edits to terminology. Like you saw, a big part of that process it doesn't mean you're creating new terminology as much as finding terminology that already exists, finding standards that already exist, and selecting the subset of those that is important for your domain or your use case. But that is the OCL authoring interface that we just saw. What's behind that is the OCL terminology service. This is a 100% REST API-based system that exposes all of the terminology content that is available in it via APIs. 100% of the functionality provided in the authoring interface is just leveraging that API. So it's a REST API first model. So that includes all of the edits and updates and things like that are applied at that level. And finally, most of the world, though, is not a dictionary administrator. They're not a terminologist. Their goal is to just consume or use metadata that has been published already. So this would be like the clinical example that we just provided. A clinician isn't interested in using the authoring interface that I just showed. They want something that's much more simple, that's specialized for their needs. It may be on a mobile device or a web browser-based tool. that is just showing content, or it's already filtered just to the content that they're looking for. So that would be the OCL metadata browser that is intended to provide a unified view of terminology that has been selected for particular domains of interest. The current tech stack that we use, OCL authoring interface, is Python and Django. It's kind of a bit older of a software application that we would likely replace with a React-based tool in the future. The OCL terminology service is Python Django as well, and it uses Solr for the search indexing, and currently uses Mongo for document database storage, and is being upgraded to, we're updating in the process now to the latest versions of Python Django, and we're going to be shifting to Postgres and Elasticsearch. The OCL metadata browser is a React-based app. So that's kind of the suite of tools. And so why is this important to have as a REST API-based system? So I'll show a couple of quick examples of this. That a terminology service, the way it is used actually in an architecture, if you imagine that you have a EMR that is capturing some patient data and it's about to submit it to, an electronic medical record, that's what EMR stands for. And so a clinician has just captured your data and maybe handed that over to a data clerk, and they're trying to enter it into the electronic medical record, and they're preparing to submit a monthly report to the Ministry of Health. They need to make sure that all of that data is validated and that it's in the right formats, and it might need to be transformed or translated into a different code system in order to, before it's moved into a data warehouse for business intelligence and data analysis. So it's a very common process in any industry, not just health. So how do we do that? So if we imagine that this terminology service is available as a REST API tool, let's just walk through a couple examples. So we looked at this concept here, and this is the malaria concept for the Ethiopia's National Health Data Dictionary, and its ID is 196. Everything here is available via the API as JSON if you just prepend it with the API subdomain there. So we can take a look at this directly, and we'll see a JSON representation of this concept. And everything that we saw on the screen before, I'm just going to duplicate this so we can go back and forth. So everything that we saw here, we will also see on this side. And we can see that there is the type is concept, and it's got its ID, it's got its class of diagnosis, its preferred display name. Here would be the list of any of the names that are available, any of the descriptions for this term, and then any of the custom attributes that are available as well. If we add another parameter here, we can say include mappings. We now get to also see any mappings that are available. Going back to this screen, is the link here to other code systems. So if in the use case where the data is being captured locally using Ethiopia's code system, so they're going to capture it as ID 196, but we'd like to report it to international partners and donors using the WHO coding system, B50.9. We would be able to leverage the mapping here to automate transformation of the content and the data to this model. So that here shows code translation. So this is one of the most common reasons to adopt a terminology service within a health system. There are lots of other kind of API-based functionality that is provided where that you would need to know in this terminology service, is the ICD-10 or LOINC code system available? So this would be asking the question, at this level. And so we'd say, if we just look here, we have org/Ethiopian HDD, that's the Ethiopian National Data Dictionary, and we're going to take a look at what sources are available in this organization, and we'll see that they have, their indicators here, they have their NCOD, the National Classification of Diseases, and some other sources. So we'd be able to use these to verify the existence of the code system. And this is also, I guess, one of the unique characteristics of this relative to other existing commercial products is that because these are commercial products, they are primarily B2B or B2G. So it is a piece of software being provided as a service to a specific business or to a government. And that would mean if the business version of this, you might have a single hospital network that has set up their own terminology service. And that means that they're going to say, here are all of the code systems and the codes that are used within my hospital network. And that's important because they're using that for billing, for data analysis, and for a lot of other reasons. And they need to have complete control over that content. And the same would be true with the government, where they would say, here are the code systems that are valid for use when reporting to the government or for reimbursement from a national health insurance system. And that they would have the same goal of publishing just the content that is valid within that health system, and it, have a requirement of it being authoritative and curated. So the difference here is that this is a shared service. And if you go back to here, you'll see we have 136 different organizations that are using this tool. We're not logged in, so we don't see any user information here. There are, with those 136 organizations have published 200 different sources, public sources. You can have private content here as well, and 1,200 collections. And these collections are essentially a way to create a subset of sources that have been published by others. And so we can take a look at that in a second. And within those public repositories, there are about 80,000 concepts, or these are the individual terms, and 200,000 or so mappings. And so because this is in a shared space, how does a government like Ethiopia then use a tool like the Open Concept Lab, if they're interested in publishing their content here? How do they use this to say, okay, we publish to a shared central repository called Open Concept Lab, but we still want to provide a website that is customized just to their content, and that so that they can guarantee that it's viewed as authoritative by their health system, and that it's fully curated content. So that is an important use case for any government. So we have another tool that I referred to called the metadata browser. So this is under development, but this is kind of getting a sneak preview of what we'll be releasing soon. So PEPFAR has the same challenge, that they're using the Open Concept Lab to publish some of their metadata, and are interested in providing a public website that shows a view just into their content that is of interest to their stakeholders. And it is critical that this be considered authoritative. And so it's not acceptable that the tool somehow is showing content from another organization that hasn't been curated then by PEPFAR. And so PEPFAR, for those who are not familiar with it, is an organization that's part of the U.S. government that provides HIV/AIDS relief. It's one of the largest HIV/AIDS donors in the world. And works in 50 plus countries providing services. So when they're trying to collect metadata or collect data from governments about their service delivery to make sure that their investments are effective. And so what you'll see here is simply a client application that is using the REST APIs. It's just built on top of OCL that is able to grab this using the same REST APIs that we just looked at, able to grab content about specific terms that their stakeholders are using to report data against. This is a pretty specialized version of it, but this is developing into something where just through configuring different JSON configuration files that you could change the branding and the style, the look and feel, and which content is displayed in this tool for your stakeholders. So why does all this matter? The terminology is a pretty, it's a very technical space. It's way in the plumbing of health systems. If you're a patient, hopefully you will never need to think about the terminology side of it when it's done right. Some of you might have heard of when Google Health and the Microsoft Health Vault, there were a few different of these personal health record systems that came out as patients began to bring their data into them. These tools would then look at their health records. Maybe it came from an insurer, maybe it came from a hospital patient record. There were some pretty high-profile issues where because of the different coding systems used by different health providers, that they were interpreting the patient's problems list or their diagnoses as something dramatically different than what it was, and sometimes way more severe. So when you do this wrong, it could actually not just lead to confusion, but it could actually lead to poor health. I'll provide another example. I don't have a slide on this. During the Ebola crisis in Western Africa, diseases do not recognize borders or country borders, as you all know, and we all know that very well now during COVID. During the Ebola crisis, that one of the ways that you are able to manage a disease like that is through rapid testing and through contact tracing. And that contact tracing means that when you identify someone that has the disease, you find out who did they talk to or interact with, and then who did those people talk to and interact with. And depending on how virulent the disease is, you may need to, you determine how many levels beyond that first person do you go. So what happens though when that disease occurs at the border and you have border towns that have a lot of trade across the border, that you may have borders that are porous where they may not have great immigration controls there, and governments need to start sharing data about those who have been diagnosed and contact tracing that's been performed. And so and that can be incredibly difficult because typically it's governments that are setting the standards for how data should be collected and reported. And there's no requirement that Ghana and Liberia report or collect data and report it in the same way. They're going to come up with their own standards for that. And there were lots of limitations then in their ability to view or to harmonize data across countries. And even more importantly, there were not data sharing agreements, so it wasn't even clear could they share this data across countries because of confidentiality concerns. So in the future, we're hoping to start developing systems that can support harmonization of patient data in an anonymized fashion. That's a big area of work now, and terminology services play a key role in that. So that's kind of the global use case example, but let's get to a really specific one just to make this really clear. So one ambulatory clinic might refer to a lab test as white count, and that's a white blood count, counting the number of white blood cells so you can measure your immune system response. So a hospital, however, might call the same test a white blood count. And for a computer to report and analyze these tests accurately, they should both be coded in an industry standard terminology such as LOINC. So LOINC is another code system, just like we talked about before, the WHO's ICD-10 or the International Classification of Diseases. LOINC, though, specializes more in laboratory tests. and clinical observation. So this is there's 100+ code systems in the world. So this is just another one of the main ones. So the terminology service piece of this, it's going to do that translation component. So any system in the national e-health architecture could then ping the terminology service and say, hey, do you got LOINC loaded? Is the LOINC code system available? If yes, then I've collected some data in my local code system called white count, and then the hospital could say, and I've collected it as WBC for white blood count. And they would then be able to use the mappings that we looked at and say both of these map to the same term, LOINC 66902, for leukocytes, and it's and you can see the clinical definition there. And now those are harmonized. And what this does is it enables semantic interoperability, and that is the foundation then of enabling secondary data use, like we talked about before. So. Because there are so many standards, that terminology services aren't just trying to map between local code systems, so like something that was developed in Ethiopia, and a global code system like ICD-10, they're also being used to map in between different global code systems. And there's lots of reasons for many of these to exist. There's different standards for drugs, for lab codes, for diagnoses, for billing codes. So you might, like for example, the standards used for clinical documentation for what you're going to actually have in your patient record looks quite different than what you're going to send to the insurance company for reimbursement. So you need different code systems for different purposes, some that help with data analysis, some that help with patient care, some that make sure you get reimbursed, and some that are used more operationally, like within a lab. So that's kind of the quick overview of OCL. We have a number of different products, like I said. We have a few different organizations that are actively involved in helping develop these, and then a larger community of volunteers that support this work. Our current tech stack is listed here. We are using Python 2.7 and an older version of Django. We did what a lot of organizations do back when we didn't know any better. We made a fork of some Django modules and have been stuck for some time on some older versions of older libraries, but we are in the process now of upgrading to the latest Python, Django. We're replacing Mongo with Postgres and Solr with Elastic, and we're preparing for I guess a model where lots of countries, lots of donor organizations are leveraging this service. So we need to be able to support a much more scalable system than we currently can. And also kind of move past some of the security vulnerabilities that this presents, and using these older modules. So but like I said, this is a very much a community-oriented system and an ecosystem that we exist because of contributions of donors and the open source community. There are lots of opportunities to get involved. If this is something that you're interested in, you can put an email here for more information about OCL specifically. The OpenHIE community that I mentioned, you can find more information about them at ohie.org. There are a lot of different software applications involved in the OpenHIE community, and a lot of different organizations and nonprofits. And many of them are using other technologies. It's not all pure Python, but definitely something of interest and a very active community. And finally, we've partnered with like Google Summer of Code and offered fellowships and internships and things like that. So if there does happen to be, this really piques your interest, and you have some time and are interested in volunteering, please do feel free to reach out. And there's a lot of opportunities for that. And I think we'll probably share these slides later. You're welcome to take a look at some of these additional resources if these are of interest. And our code is all up on GitHub and open repositories, and you can feel free to take a look there as well. So Thank you so much for your time. I hope this has been enjoyable, and hope to hear from some of you soon. And again, there's the email, and please feel free to reach out.
Awesome. Thank you so much, John. Everybody who's watching, make sure you give John a round of applause in the Slack there. I know that we always want to make sure we give some feedback to our speakers, and not being able to be on the call, we want to make sure we can see that some way. So again, John, thank you so much. I do have a few questions. One, I'm going to start with my own because I have a question. How did you kind of get involved in this space? Like what led you to like Rick and Streif?
Yeah, so as an engineer, I went to graduate school for public health, and I had an experience where I started speaking with different faculty about, how do you bring more IT and software engineering skills to bear within the public health world. There's an incredible amount of opportunity and need. However, the public health academic world is still pretty old school. They're very focused more on there's a lot of different things, but demography and vaccines and things like that. And so they all were like, you got to talk to this one guy. And it's a faculty member who had built a wiki page. And that was like the guy who had the tech skills. So it was, I think, so it was clear that there was a need and an absence of a formal understanding for how to leverage software engineering, especially within the public health community, especially within international development. So I got really interested, did some internships, went to Zambia and Kenya and visited clinics that were using EMRs, electronic medical records within HIV service delivery, and really felt that fit what I wanted to be doing. And so there are now a lot of public health organizations and nonprofits that are bringing in-house engineering expertise, and if that's the kind of thing you're interested in, it can be really exciting work.
Super, super cool. That's awesome. I'm actually, stole a word right out of my mouth. Have you seen an uptick in interest in your project since the COVID-19 pandemic onset?
Absolutely. So this happened with COVID-19. It also happened with Ebola. When a new outbreak occurs, it is critical that data be shared in a timely manner and in a way that can be harmonized. So it's kind of the core challenges of what we just talked about. So that part of that means, how do we really quickly capture all the ways people are coding the data that they're collecting, and begin to harmonize it and then provide guidance. So groups like the WHO and different governments need to be able to publish their guidance. So we actually have a COVID-19 value set, which describes about 150 or so codes that are commonly being used within COVID-19 response. And there are some other groups that are doing similar work, and we're intending soon to start harmonizing that. And so, yeah, it's definitely a common challenge with terminology services.
Definitely. A few more questions here before we have to head out to the breakout room. What is the peak load?
So we are, the peak load tends to come when we are doing some pretty heavy ETL work, when somebody's submitting a custom file that where we need to translate thousands of codes to custom codes to a different format. And I guess I don't have exact numbers on what that would look like, but we definitely have hit our peak load frequently as of late. So
Sure, definitely. And do you have cases that don't have one-to-one mapping? How do you handle such cases?
Yeah, tons. So I think that the whole challenge of, there are reference vocabularies, which are the global standards, and then there are local code systems. And local code systems can be modeled really well, and sometimes they're not modeled so well. They're often not. So the ones that are not modeled well, a single term could actually map to many other terms because maybe it's not specific enough. It's not accounting for all of the different qualifiers that you might need. So you usually wouldn't just diagnose someone with malaria. You would have a much more specific diagnosis of malaria. So if you have captured data, though, that all you did is say, malaria, you don't know, was that a rapid diagnostic test done in the field? Was it a laboratory test? So you see that a lot, where once you bring a terminologist in to help support mapping of a local code system, each term will typically have many maps, and then the solution to that is to do more curation. Like, you really need to revise the code system to get to a point where you have the specificity that allows you to do data harmonization.
Mm-hmm. For sure. Ben, Cameron, I see that you both also have questions, but unfortunately we run out of time here on the live stream. But we do have the breakout room that John will be in here momentarily. John, thank you again for being part of Python WebConf. It's been a blessing to have you.
Thanks so much, and appreciate the opportunity.